Hi everyone, today start now the types of differential amplifier. Okay, even though differential amplifier is designed to have two possible inputs and two possible outputs, it is not necessary to use both inputs and both outputs. So, based on the methods of providing input and taking output, differential amplifiers can have four different configurations. It is the four different types. Okay. In that, first is the single input unbalanced output differential amplifier. Second type is the single input balanced output differential amplifier. Third type is the dual input unbalanced differential amplifier, and fourth one is the dual input balanced output differential amplifier. Okay, in that first type we see the single input unbalanced output differential amplifier. Okay, in this case only one input signal is given and the output is taken from only one of the two collectors with respect to ground. Okay, in the figure shows when input signal Pin1 is applied to the transistor Q1. It's amplified and inverted voltage gets generated at the collector of the transistor Q1. Okay. Inverted voltage gets generated at the collector of the transistor Q1. At the same time, it's applied and non-inverted voltage gets generated at the collector of the transistor Q2. Okay, in this figure shows this is due to effect of input voltage Vin1. Effect of the applied input voltage Vin1 is coupled to the transistor Q2. It's coupled with transistor Q2 via the common emitter resistor. Here connected common emitter resistor Re. Okay. Unbalanced output will contain unnecessary DC content as it is a DC coupled amplifier. Unbalanced output will contain unnecessary DC contents as it is a DC coupled amplifier. Therefore, this configuration should follow by the level transistor circuit. And in this type, gain AD is half than that of the balanced output type. And the output of this amplifier is this type of the amplifier is Phi out is equal to AD Phi in 1. Output voltage Phi out is equal to AD Phi in 1 as the Phi in 2 is equal to 0. That means the ground. Where in that equation where Phi out is the output voltage. AD is the gain of the differential amplifier and it is the RC upon 2RE. RC is the collector resistor, 2RE is the both transistors emitter terminal connected resistor 2RE, and Vin1 is the inverting input and Vin2 is the non-inverting input. Okay, this is the first type of the differential amplifier, single input unbalanced output differential amplifier. Okay, then second type of the differential amplifier is the single input balanced output differential amplifier. Single input balanced output. Okay, in some applications only one input is needed. While other is grounded. While other second terminal is the input terminal is the grounded, such amplifier is called single-ended input. In this type of the amplifier is called as a single-ended input and balanced output. Same as above, only one input signal is given. Even though the output is taken from both collectors. Okay, output is given in the between the two collectors. Okay, this will give us more amplified version of output as it is combining the effect of both transistors. Combining the output is gives to the combining the effect of the both transistors Q1 and Q2. As gain AD is double than that of the unbalanced output type. Double than that of the unbalanced output type of the amplifier. There won't be any unnecessary DC content in balanced output, as the DC contents in both outputs gets the cancelled each other. Okay, in this type of the amplifier, output of this amplifier is phi out is equal to AD phi in 1, as the phi in 2 is equal to 0. 0 means the connected in a ground. Okay, phi in 2 input second is connected to the grounded, where the in that equation phi out is the output voltage. AD is the gain of differential amplifier. AD is the gain of the differential amplifier, and it is RC upon RE. It is a RC upon RE. Okay, and V in 1 inverting input and V in 2 is the non-inverting input. And this differential amplifier has floating load, that is both end are required load at collector. And this is convenient because load is generated single-ended, that is one terminal of load is connected to ground. Okay, one terminal of load is connected to the ground. Okay, in this second type of the differential amplifier, single input balanced output. Okay, then next third type of the differential amplifier is the dual input balanced output differential amplifier. Dual input unbalanced output differential amplifier. Okay, in that both inputs are given in this case, that is differential input. That is differential input, but the output is taken from only one of the two collectors with respect to ground, as shown in the figure. With respect to ground, as shown in the figure. This is widely used differential amplifier configuration. This is configuration is the used in a widely, as it drives a single-ended load, where in one transistor is emitter followed and other is the common emitter amplifier. Okay, in that one transistor is the emitter follower and other is the common emitter configuration or amplifier. In that, amplified version of difference in both signals will be available at the output. Okay, in that the amplified version of difference in both signals, phi in 1 and phi in 2, will be available at the output. Okay, and the voltage gain is half the gain of the dual input balanced output differential amplifier. Okay, voltage gain is the half of the gain of the dual input and balanced output differential amplifier. Okay, in that unbalanced output will contain unnecessary DC contents. Okay, unbalanced output will contain the unnecessary DC content, as it is a DC coupled amplifier. As it is DC coupled amplifier. Therefore, this configuration should follow by a level transistor circuit. Okay, level transistor circuit. Okay, in this type of the differential amplifier, output of this amplifier is phi out is equal to AD in bracket phi in 1 minus phi in 2. Okay, where in this equation phi out is the output voltage. Phi out is the output voltage. AD is the gain of differential amplifier. AD is the gain of differential amplifier, and it is RC upon 2RE. RC upon 2RE. And phi in 1 is the inverting input and phi in 2 is the non-inverting input. Okay, in this type gain AD, in this type of the differential amplifier, gain AD is half than that of the balanced output type. Half than that of the balanced output type. Okay, then second type of the differential amplifier is dual input balanced output differential amplifier. Okay, dual input balanced output. Okay, in that such an amplifier has two inputs. Such amplifier is connected two inputs V in1 and V in2. The output voltage V0 is voltage between two collectors. Okay, output voltage is measured in between the two collector terminals. Okay, the circuit is symmetrical with identical transistors and collector resistor. Circuit is symmetrical with identical transistors and collector resistors. That is the V out is equal to 0 volt. That means the output voltage is equal to 0 volt. When V in 1 is equal to V in 2. V in is equal to V in 2. But in that, when V in 1 is greater than that of the V in 2, V in 1 is greater than that of the V in 2, then V out, that means the output voltage, appears with shown a polarities in figure. Polarities in the figure. And when V in 1 is less than that of the V in 2, V in 1 is less than that of the V in 2, the output voltage V out appears with opposite polarities than that of the previous one. Opposite polarity is the previous one. That means the applied signal. Okay, then output gives in a totally opposite polarities. Okay, then for effective operation, in that components on either sides should be matched in a properly. Input signals are applied at base of the each transistor. Input signals are applied at base of the each transistor and output is taken from both collector terminals. Okay, output is taken from the both collector terminals. There won't be any unnecessary DC contents in balanced output. At the DC contents in both output get cancelled in each other. Both outputs gets cancelled in each other. Okay, this has double-ended input. Okay, V1 is called non-inverting input and output voltage V out is in a phase with applied input V in 1. Okay, in that V in 1 is called as a non-inverting input as output voltage V out is in a phase with applied input V in 1. While V in 2 is called the inverting input. As output voltage V out is in 180 degree out of phase. Okay, output voltage is in a 180 degree out of phase when the V in 2 voltage is inverting input. Okay, with applied input in a V in 2. This differential amplifier amplifies difference between two input voltages. Okay, in this type of the differential amplifier amplifies difference between two input voltages producing output voltage V out. Okay, producing the output voltage is V out. Okay, gives the output voltage of amplifier V out is equal to AD in bracket V in 1 minus V in 2. Okay, V in 1 minus V in 2. Where in that equation V out is the output voltage across the collector of two transistors. Okay, output voltage of collector of the two transistors. Okay, AD is the gain of differential amplifier. AD is the gain of the differential amplifier. It is the RC upon RE. V in 1 is the inverting input and V in 2 is the non-inverting input. Okay, applied first input V in 1 is the non-inverting and second V in 2. That means the second input is the non-inverting input. Okay, here completed the classification of differential amplifier or types of the differential amplifier. Okay, stop here. Okay, thank you guys.